Hi everyone, today in Integrated Math 1, we're going to go over Chapter 12, Lesson 4. Here are the objectives. Make sure you write them down in your notes. Alright, so our first postulate is the side-side-side congruence, also known as SSS congruence. So this is when if three sides of one triangle are congruent to three sides of the second triangle, then the triangles are congruent. So, as you see here, it's saying for side AB, that is congruent to side DE. Notice they are marked only once in both triangles. So this one's marked once, and this side is marked once. That's showing congruency. Then we also know that side BC, so BC, is congruent to side EF. And EF is right here. And our other side, AC, has three tally marks, and that is congruent to the other side, DF, which is our only other side left. That's perfect. So with this, we can make our congruency statement. Remember, congruency statement is when we're saying one triangle is congruent to the other. And the order for this really does matter. So triangle ABC is congruent to triangle DEF. And let's double check this. Side AB is congruent with side DE. Side BC is congruent with side EF. BC, EF. And then we have side AC should be congruent to side DF, which is exactly what we said. So this is true. Alright, so next we have the postulate 12.2. That's not important. What is important is that it's a side angle side congruence, also known as SAS. So this is when if two sides and the included angle of one triangle are congruent to two sides of the included angle of a second triangle, then the triangles are congruent. So let's look at this. We have a side. We're talking about side AB. Side AB, we're saying that must be congruent to side DE. So notice they both have one little tick mark here. Then we're talking about our angle. Side, angle, side. So our angle that we're looking at is angle B. Angle B is congruent with angle E, which is what we said. So perfect. Then we're saying side BC. BC has two little tick marks, is congruent with side EF, which has two tick marks as well. So that's perfect. So now we can say that triangle ABC is congruent with triangle DEF. So our first side that we're looking at is AB. AB should be congruent to DE, which it is. Then we have our angle B and our angle E, which should be in the middle. We have B and we have E. So side, angle, now let's check our side. BC should be congruent with EF, which it is here, and it's showing here. Notice how we have a side, angle, side. It doesn't go side, side, angle. It must go in the order of side, angle, side. And they're right next to each other every time. Alright, so here we're going to show congruent triangles. We're going to first try side, side, side. So we have our side, we have our side, and we have our side here. Notice here how this one is not forming a triangle yet, but we can see if we can make a congruent triangle here. And you can see how it's very particular where that spot is where we can make a triangle. That's because all the sides must be congruent. And now you can see that turn to green because they are now congruent triangles. Alright, so next we want to prove side, angle, side. We have our side, which is right here. We have our angle in between here, and we have our other side here. As you can see, it's not forming a triangle quite yet. We want to see if this actually can be a true statement. So let's see if we can rearrange them to make sure it's a true statement. And you see with me adjusting the leg here, it has made it a true statement. And there you go. So you've proven side, angle, side, side, angle, side. And they're both congruent now. So if you were to overlap them, you would see that they are both exactly the same now. And then that's it.